Welcome back, trainers, in another video. Right, this time around we are going to discuss something about the conjugate surds. Conjugate surds. It might look as if it is a new terminology, maybe big deliberate word, but rather when we start discussing, if it's just like a simple and very friendly surd. Right, in surds, there are some expressions that we call them as conjugate surds, and we need to know them. And why should we know them? So know for sure that whatever we're discussing, it is paramount in the next discussion. So please stay tuned and understand this one very well, and really have to understand what is a conjugate surd and what is the story behind it. So it means the next discussion, you see how important this one is. So this time around, I'll just discuss what conjugate surds are. In the other video, we are going to discuss how important the knowledge of which is then. Right, the moment I'll use my chart here, which will help us to understand very well about the meaning of the conjugate surds. If you say we have conjugate surds, actually what do we mean? Right. It's not as difficult again. The word is not again at least give panic in your head. Say what type of mathematics you have now? I just friend it. Take this and move on. Now heading towards the end already. Fine. When we talk of conjugate surds, first of all define it. Then we're going to discuss here. Right. Conjugate surds are just any two surds. Simple and clear and direct. Any two surds. But what surds? Whose product give a rational number? Right. You know what it means by product? Just multiplication. So if I've got two surds, right, that when we multiply and the result, talk of the answer, is a rational number, then those surds, you call them as conjugates of each other. So you see the definition, it's just clear. So it means the conjugate of surds, conjugate surds, it's just like a friendly way and well accommodated in your head. Right. Any two surds whose product give a rational number. And remember what we defined about the rational number in the previous video. If you can't remember, still more here, there's a link down here. You can go back to the previous video and try to understand what the rational number is. Right. Just to remind you a bit, the rational number is a number that can be expressed in the form of A over B, where B is not what? Is not zero. It's not equal to zero because that is undefined. So it's more just like a number that can be expressed in the form of what? A fraction, where the top number is regarded as the numerator, the other one is what? A denominator. So the result of the product is giving me a rational number. Right, that's the thing. Now, here, maybe for us to understand this one better, let us have the example. What is it about this definition? Right, look at this. Example 1. Here I have a surd, root of a 3. This is a surd. We all know it. Right. So here I have another surd, root of a 3. Just like another, just example. But here I also have another scenario in the same discussion. Root of talk of maybe a 3, and here I have got a root of maybe of what? Of 7. Look at this. So if I may try to multiply this and this, a product of that, the product means multiplication, and I also multiply here. We have got two surds here. This is a surd, that is a surd. This is a surd, that is a surd. If I do the operation for this, I'll get root of a 9. If I do the operation for this, I'll get root 21. So if we compare the two results from this example and that example, you observe that here we're getting root of a 9 as what? A 3, which is the same as the 3 over 1, which is rational number. But here now, in the other example, you find that if you take the square root of 21, it ends there. There's nowhere else you can go. So now, if we compare the two by the definition we have here, you'd really see that if we multiply this one by that, these are the two surds which are multiplied here, and they're giving a value which is the 3. That 3 is a rational number. Then we say root of a 3 and root of a 3 are conjugate surds. So it's more like root of a 3 is a conjugate of itself. That's what we say there. Right. But now if you talk of a root of a 3 and root of 7, this operation in multiplication, it gives us root of 21. If we talk of root of 21, is not a rational number. So this is irrational. It's just a surd itself. Right. So it means root of a 3 and root of a 7 are not conjugates of each other because they don't give you what? A rational number. Hopefully this is very clear on that definition by the example which I've given you here. Right. So similarly, if we can look at again example, the next example here, 5 root of a 2 multiplied by 5 root of a 2, which gives us 50. You'll be able to see that again, that the 2 root 5 root of a 2 multiplied by 2 root of a 5. From that, give us root of a 2, that's the total 5 root of 2 multiplied by 5 root of a 2. This one should be 5 here. Sorry for lighting like that. This is I did the opposite here, but the 2 should be inside like that. By the previous discussion we had in the multiplication of surds, we said numbers can multiply by themselves. It means here we have got 5 times 5. We get 25. And again, root 2 times root 2 is as good as lighting 2 times what? You talk of a 2 in this case. At the end, you have got 25, which gives you root of a 4. If you have got a root of a 4, it's typed there, you're getting what? 25 times what? A 2. And this gives you what? 50. Look at 50. 50 can be expressed in the form of A over B, which is the same as what? Lighting as what? 50 over 1. Fine. Then we call what? Root 5 root of a 2 and 5 root of a 2 as conjugates what? Surds. Why? The product of which are giving us what? An answer which is rational. Simple as that. Right. So before I go to another category of the conjugate surds, let me just at least summarize on this one here, because there are some kind of mathematical statements that we need to describe this. Yes, we understood that there are conjugates of each other, but now how do we express ourselves each time we are to talk about that? Right. Now, from the 2 examples, we will check that they are really giving us a rational number, thus the product of the root of a 3 by itself. We say that say root of a 3 is a conjugate of itself. That's what it means there. And again, here we talk over 5 root of a 2. This one is also, you can talk of that one as the 5 root of a 2 is also a what? Conjugate of itself. Right. Or the other way around, you may say, somebody might ask you, what is the conjugate of a root of a 3? What is that person trying to ask you? It's just a matter of asking to say, what can be multiplied by a root of a 3 to get a rational number? So here it means you talk of another root of a 3. What about the conjugate of 5 root of a 2? It's the same like say, what can be multiplied by 5 root of a 2 in order to get a rational number? So there you always talk of what? 5 root of a 2. Right, so that's what it means in this case. When you talk of the conjugate surds, we are just referring to 2 surds which are in the operation of the multiplication, and the result is what? A rational number. Right, now let us now extend our discussion on the conjugate surds to the expressions which are in the form of a minus b and then a plus b. Let's look at what we have here and what we get. Right. We all know from the previous discussion that we had in JCE that each time we are multiplying terms in the form of a minus b and a plus b, we always know that this one gives us a difference of 2 squares, like that. And you can just try to expand this one. You know, you are mathematicians. We don't have to go into business multiplying this by this. It's just like a times the whole of this bracket and minus b times the whole of that bracket. You definitely going to get what? a squared minus b squared. That's the form. Right. So here you'd see that if I've got this type of scenario and apply it again in the surds to say every time I've got this presentation, a minus b, a plus b is equal to a squared minus b squared, you'll be able again to observe that if surds are also expressed in this manner, they'll always give you difference of two squares. And at the end of the story, the value that you get, you always get a what? A rational number. Then we may also regard such type of surds in that form as conjugates of each other. Right. For example, look at this. I may have root over 2 plus 1 multiplied by root over 2 minus 1. Look at this. This is as good as root over 2 is just like a. Right. And you have got this minus. Let me begin maybe by writing a negative here, but that carries no effect. You can still have a positive there, negative. It doesn't matter. But one bracket should be positive, another one should be negative. Here there's root over 2, here there's a. Minus 1 is just like minus b. Minus positive root 2, this is just like a. Positive 1, just like positive b. So now, this is as good as writing that. So here it'd be like, when I have got this format, I know for sure when I expand this one to give me difference of two squares, then definitely this one will be like, as I'm squaring a to get a squared, it means again here I'm also going to square root over 2 squared. Here it is minus. Here I'll also have a minus. B squared, it means another term, which is identical to the first bracket there. A term in the first bracket, which is the b here. So it means here you also have what? 1 squared. So what do we have there? If I square this, it is as good as having 2 multiplied by 2 in one root. And here it minus 1. And then that, what do I get from there? I'll get, let's say, a value which is root over 4 minus 1. And square root over 4, it is a 2. 2 minus 1, the answer is 1. Right. So just 1, writing a 1, 1. That is the same as writing 1 over 1. So it means 1 is also a what? A rational number. So you can see here such expressions of this kind. They are really giving us a difference of what? 2 squares like this one. So some of you might be saying, but now, is that really true? That saying when we write like this one, is it straightforward that we need just have to square like this one? The answer to that, yes, is correct. Unlike involving yourself into such type of expansion, yet you know that this one are in this form. Let's try to at least maybe prove it out. Does this expansion going direct like this one give us a 1? So what we will do here, we'll try to expand this one now directly to possibly see if we can get a 1, so that we should accept this type of presentation in mathematics. Right. Let's look at this. Instead of coming direct, this one multiplied by this, we just come straight here. In our case, we work out that one by different procedures, the one we already know. So here, it means I will write this one up here, root over 2 minus 1, and then root over 2 plus 1. This, it will be like that, what you know, expanding the brackets. Take every term with the first bracket, multiply by the next. So here I'll begin with the root over 2. Product this, root over 2 plus 1. Then I'll take minus 1, have it here. This one, it will be multiplied by this, root over 2 plus 1. And then what do we have? Root over 2 times root over 2, you always get what? Talk of what? A 2. Because root over 2 times root over 2 just like root over 4, which is a 2. And then root over 2 times the 1, that one will give you positive root of a 2. That's what you have there. And then here negative 1 times root of a 2, you get negative root of a 2. That's what you get there. And then you have got the negative 1 times the positive 1, there you get what? Negative 1. Look at that. So what do you have here? It'll be like a 2 here. Then this minus this minus this, give us a 0. And then what do you have at the end? We have got minus 1. So see this. What do you have? 2 minus 1. Give us what? A 1. Look at that. Right. So as a mathematician, I don't think that each time we see the brackets or say we have got expressions in the brackets which have got identical terms like root 2, and in a different, in one bracket there's negative, another one is positive, it's certainly that we just have to conclude to say that is just about the difference of two squares. Clearly, what is needed there, just the square direct. I just have to square this one and then subtract, not addition. We're talking of difference of two squares. So really, the operation of a minus b, then a plus b, anything represented in that form, you just have to clear it out just by squaring out the terms in which, and then you subtract the term because they're just like the same. But if they're different, please do not apply this. It's only for the difference of two squares as such. So now you can see here, I was multiplying this by this. And what do I get? I get a 1. What does the definition say? Any two surds whose product give us a rational number, the conjugate surds. So we have extended this knowledge here into expressions which are multiplying. So since here I was multiplying root 3 by root 3, give me a 3, and I conclude that 3 is a rational number, then root of 3 and root of 3 are conjugates of each other because they are following this definition. Then why can't I conclude here to say that this and this are conjugates of each other? Then that is also true in that kind. So it means the root of a 2 minus 1 and root of a 2 plus 1, those are conjugates of each other, the two of them. And somebody will come in sometime to ask you, my friend, what is the conjugate of root of a 2 minus 1? He's trying just to ask you to say, what can be multiplied by this expression in order to get that as a rational number? So there, be quick, nothing else. You should be able to have another expression of terms similar to the existing expression. So you should also tell me it's the root of the 2 itself, but now since here there's negative, but now the other expression should contain what? A positive. Possibly there. So let's try to expand this one. Don't go into this type of what? Processes. You realize that these are conjugates of each other. Just expand, just square one and square the other one. And then subtract as we have done what? Here. You get the answer. So it means this kind have got two operations. Either you can go by the difference of two squares, or you can expand what? Directly. So please try to check each time you are multiplying the surds. Check if you have got the binomials, because these are binomials, two termed expressions are multiplying. If you have got that type of presentation of a minus b, a plus b, please just go straight here into difference of what? Two squares. Right. So similarly to this one here, you'd find that this example, number 2, if we can discuss together here, look at this, what will be for it? Look at this one. Very interesting. Right, I have here 3 root of 2 minus 2, product 3, okay, product root 3, 3 root 2 plus a 2. As a mathematician, this time around, you have learned about the conjugates of the expressions. This can also be extended to other expressions, not only for the surds. You'll be able to see that, why should I take of this one multiplied by that, this one multiplied by that? No, don't go for that. You should already see that this one, this expression is already in the form of what? That is a plus b, then what? A minus what? A minus b. What should you do? This one tells you what? A squared minus what? B squared. So what you do the same here, this should be represented by a. So it means you have to square this one out. Then what do? Present in that format. Minus what? B squared. The b squared in this case is what? Is your 2. So you substitute this one for the what? For the 2, that one squared. Just like that as brief. So if somebody will operate this one by this, you get the same answer. So don't have to waste time with that. Just expand by following the difference of two squares. So now what do we have here? This is as good as if you go for a long simplification, you go for like 3 root 2 times 3 root 2. That's what we go. So here you have got a 9 times root of a 4, and which is a 9 times 2, and you get the answer as what? 18. But now we don't have even again to go by that. Direct as a mathematician, you can know if we're squaring this, it means the 3 has to multiply by itself, which gives us a 9. Look at that. This one, it means root 2 multiplied by root of a 2, which the answer will be root of a 4. Root of a 4 is what? Is a 2. So it's just like root of a 2 by root of a 2. The answer is what? It's a 2. And here you have what? A 4. So here it means what? 18 minus what? A 4. And the answer you get is what? 14. So if you look at 14, 14 is what? A over B is a rational number. Right. So here we will say that's would say this as to say the conjugate of 3 root of a 2 minus 2. Right, that's a talk of the talk of this one is a conjugate of what? 3 root 2 plus what? Root 2. Right. If somebody asks you, what is the conjugate of this? It is the same expression, but with different sign. Thing like that. So I think students say, by this simple discussion, just the definition of the conjugates of each other, we should be able to understand. If each time we talk of the conjugates, remember the procedure or the knowledge behind it. We're just looking at the surds that can be multiplied, extended to which expressions that can be multiplied. The results should be what? A rational number. And you'll be able to mention that this is the talk of the, this one is the conjugate of the other. You'll be able to mention by that as we've just done here. Right. Like now in the last example, where I'll just give you a very simple example. I just need you to state the conjugates of the following. You'll be able, I think, to do it out. Right. Let's look at this one. I've got A, 3 root over 7 plus 5 root over 6. And has over have a B, 7, maybe minus 2 root over C of what? Of a 9. Not 9, but let's have 11. Right. Somebody asks you what are the conjugates of this? Quickly, just indicate the same thing. 3 root over 7, but now should be minus 5 root over 6. Done. What the conjugate of this? You also have to be quick and just write it. That's the talk of what? 7 now plus 2 root of 11. Simple that. So which means if I multiply this by this, I'll get a rational number. And multiply this by that, I get what? A rational number. Right. By this, at least encourage your students to go and at least revise from the starting point up to here we are in this video, so that you follow what we've been discussing. Because this is what we've just discussed in the videos, the previous video, and this video will count in the next, which is the last discussion of our topic here about the surds and the irrational numbers. So please go through them. They're just very simple procedures to be followed. And each time, remember what we're doing, we are aiming at knowing how we can simplify the surds as such. Right. So before I leave the setup, still as I do, I can't just leave the setup. I have to at least to give you something that you can try. But now I want you to make this one very simple, in a simple method as such. Right. So what I want you to do in the same example which I've just given you here, where I was asking you to state this conjugate of this and that, where the conjugate of this is this, the conjugate of this one is that. I want you to at least now go phase of that. To have this, can you evaluate? Talk of 3 root 7 plus 5 root over 6, then multiplied by 3 root 7 minus 5 root over 6. The same for that other one. You have got 7 minus 2 root over 11. Product is 7 plus 2 root of 11. Right. So A and B. So I'll ask you to use the two methods. One, the direct expansion, where this terms multiplied by all the terms in the next bracket, and the same terms here multiplied by all the brackets. And the other one should be that simple one about the difference of two squares, because we have already evaluated that these are conjugates of what? Each other. So compare the two methods and the type of answer you get, you will be able to see that they are just the same. And you're really going to bear and capture this knowledge as really valid. Right. So as usual, please try to go through all the videos so that you should be able to understand this topic clear, and you have to revise now and again by replaying the videos now and again until you finish up the lesson. Thank you very much.